there is an ant that travels from point P to point Q, which is a distance of 60 centimeter apart in 2 minutes. That means traveling from P to Q took 2 minutes, which is a 60 centimeter distance. Then what they are saying is we have to find rate at which the distance between ant and its image changes. Okay, so one more, the direction in which it is traveling, that is making an angle of 30 degrees. Okay, now you see it is a plane mirror. So from a P, if I drop a perpendicular, I will get object distance. For plane mirror, object distance and image distance are same. So let the image of ant be at P prime. That means the P is the location of ant. P prime is the location of image of ant. Then this ant kept on traveling to Q, and now Q is the location of the ant, and from Q, if I drop an altitude, I will get object distance. Okay, M P prime or P prime M is the image distance. Okay, so from Q, when we drop an altitude, we get object distance, and always object distance and image distance is the same for a plane mirror. So Q prime is the location of the image of the ant. Okay, and then we need not connect this line. Just to show you symmetry, I have connected this line. Right, now they are saying that rate at which a distance between ant and its image, rate at which the distance between ant and its image means what? This length, rate at which this length P prime changes, rate at which a distance between ant and its image changes. That means rate at which the distance P prime changes. That is P prime became Q prime. So what a distance in what a duration, that is what we have to find. Okay, so for this purpose, what happens, in the hint they said use trigonometric ratio, those all, but actually either we use trigonometric ratio or similarity concept, because only we know this angle 30 and we know this distance PQ. We really can't find any solution with this diagram, but we can do something else. Okay, one more thing. You first see this rate at which a distance between the ant and its image changes. Okay, so that means we have to find rate at which P prime, this distance becomes Q prime. That is, at what rate this distance gets converted to Q prime. Okay, and whenever they say us rate means what? With respect to time. Okay, change in a distance. Okay, change in the length. So that is P prime minus Q prime. Okay, so this is the change in distance. Change in this P prime becomes Q prime, and we have to find a rate at which this is done. Rate means what? With respect to time. So exactly this is what we have to find. Okay, so we Q prime. So whenever they say change, we have to find a difference. Okay, so the difference of distance between the ant and its image. Okay, so the distance between ant and its image, first in the beginning was P prime. Later, it became Q prime. So we have to find rate of a change. Rate means what? With respect to time. Change means what? Change in the distance between the ant and its image. That's it. Okay. So that question statement, it's still there on the screen. What is the, just a moment, what's my screen doing? Can I write? So what, you see the question is still on the screen. What is the rate at which a distance between ant and its image changes? Okay, distance between ant and its image is the P prime. It was beginning. After some time means what? After 2 minutes, a distance between and its image became q prime. Whenever we have to find a rate of a change means what? Subtract the initial minus final. Rate means what? Divide by time. Okay, so that's how. All right. Is that okay?
Yes, ma'am, I'm getting.
All right. So now what happens, how the hint is written in the book. No, if I follow the hint, I'm sure we will find difficulty in solving. So what we do is we modify the question. How to modify the question? You see, very simple. We have the same mirror. Now, what we do is we just shift the mirror to point Q. Means what? Q perfectly comes on the mirror. So this is a Q. This itself is and this itself is a Q prime, and's image. Okay. And before we had a P, which is the location of the and we have P prime, which is the location of the and's image. Okay. So actually P prime Q, I need not join, but just to show the symmetry of the diagram, I'm doing it. This angle is 30. You see, in the actual diagram, this mirror, M prime, if I just horizontally shift to Q, I will get the mirror somewhere here. Okay, if this angle is 30, so this angle also has to be 30, corresponding angles are equal if lines are parallel. Okay, it is something like mirror M prime. I have raised and taken it up to Q. Okay, and now I'm talking about the upper triangle PQ with the mirror. Okay, so that is the current diagram that I have drawn. Okay, so the mirror is this one, M prime. Okay, and this is object distance and this is image distance. For a plane mirror, object distance should be equal to image distance. Okay, that is one point. So we have to find this one only. Still now, rate at which the distance between and its image changes. Rate means what? With respect to time. Distance between and its image is a PP prime. After after 2 minutes, distance between and its image is QQ prime. That philosophy is still there. Okay. So now complete thing is we have to find U. For that purpose, what we'll do is we'll apply one of the trigonometric ratio to the triangle. Say this point is R, to the triangle PRQ, to this triangle. All right. So what we do is a 30's opposite side is our requirement and hypotenuse is given to us. That is a 60 centimeter in 2 minutes time. Okay. So in triangle, yeah. So in triangle PRQ prime, we will take sine 30 because sine of an angle, sine of an acute angle is the opposite to hypotenuse. Hypotenuse is a PQ. Sine 30 is 1 by 2. U is our requirement, means object distance, and PQ is a 60 centimeter. Okay, and then we know this, and then we will get object distance as a 30 centimeter. And since object distance is equal to image distance, both of them should be 30 centimeter. Okay, right. So the answer now, the rate of change of object, that is and its image, that is ant's image, is P prime. No, so see, P prime minus QQ prime by time. Okay, the same thing. Okay. Right. So what is the PP prime? PP prime distance is the object distance plus the image distance, which are same, equal to each other. QQ prime is in fact a point in our converted diagram. So a point has no dimension. So QQ prime distance is 0. Time is 2 minutes. Okay. And then you have U, which is 30 centimeter. U and V both are same. So this is also 30 centimeter. 30 plus 30, 60 centimeter. So let us convert this into centimeter per second form. So 2 into 60 seconds, which is the 1 by 2 centimeter per second. So this is the rate. Half centimeter per second, 0.5 centimeter per second will be the rate at which the distance between ant and its image is changing at trigonometric ratio. In triangle related to Q, M prime and the small triangle, there no side is given. Whereas for the bigger triangle, only PQ is given. So we can't solve. So this is what we can do. Okay, right. Object is placed at a distance of 20 centimeter from pole of a concave mirror. Okay. So we have a concave mirror and I will follow directions that is given in the question. So this is the concave mirror. So this is the pole of the mirror. Object is placed at 20 centimeter from the pole of the mirror. So this is the location of object and object distance is 20 centimeter. Okay, sign conventions while solving we will put. Okay, so object distance is 20 because it is in the left side. We will take minus 20 centimeter. The question went for a continuation. Magnification of its real image is 3. Real images are inverted. So magnification is 3, but it is a real. So you have to take a minus symbol. If it is a virtual, we'll take plus symbol. That's it. If the object is moved away from the mirror by 10 centimeter, okay, so this is case 1. That means from case 1, we have to pick up some details. And then we have case 2. In case 2, they are saying if object is moved away from the mirror by 10 centimeter. Okay, so if object is moved away from the mirror by 10 centimeter, we have to find a decrease in image versus a concave mirror. And then they said that an object is placed at 20 centimeter in front of it. This object's image is real and it is 3 times magnified. That means image is formed below. Okay, if this is x, this is 3x. But it is formed below the principal axis, that is by minus 3. So these two are given. What we have to do is, first from these two, we will find out the focal length of the mirror. So using this information, we'll find focal length of the mirror. Once we know focal length, then we have the new object distance for the second case. New object distance is what? The object is shifted away from the mirror by 10 centimeter. So before it was 20, now an additional 10 centimeter. That means object is at 30 centimeter to the left of mirror. Means what? Object distance is minus 30. And then from the case 1, F we will use, and then we will find a magnification. Then second magnification and the first magnification, when we subtract, we will get the decrease in magnification. So this is in stages. Okay, so yeah, don't panic when I say these many words at one time. Okay. So here they said, yeah, they gave us object, this, and I said, unless we know focal length, we can't find magnification also, no? So we have a formula called magnification is F by F minus U for mirrors, and magnification is F by F plus U for lenses. Okay, mirrors, for mirrors, you see, magnification is minus V by U. Okay, So from here, we can get image distance as minus mu. Okay, so keep this in mind. And then we have a mirror formula, which is a 1 by f, which is a 1 by v plus a 1 by u. And then what I do is, in place of a v, I will write a minus mu. Okay, then I draw demarcation here. So we have a 1 by f is, I'll take LCM, we'll have here mu, and here minus 1 plus m, all right. And then if I go for cross multiplication, I'm deriving the relation between these three terms. Okay, unless I have a formula connecting these three, I can't find focal length. For that purpose, I'm getting the formula ready. So we have here mu, magnification m, u is object distance, which is minus f plus mf. Okay, put like terms together. Like terms together means you just do a small transposing of these two. So f will be mf, the object distance and magnification of a mirror. Okay, and right throughout, yes, yeah. So this is a formula. So I'm going to use this formula. Okay, so for mirrors, magnification is f by f minus mu, and for lenses, it will be just a small difference, f by f plus u. We can do the same derivation to get this one. In lenses, we'll have magnification as not minus v by u, it is plus v by u. And lens formula will be 1 by f is equal to 1 by v minus 1 by u. So there, if we plot v, we will get the second formula. All right. So right now, this one. Okay, so that we don't miss out on what we are discussing, I put that question part there. They said very simple thing. They said object is placed at 20 centimeter in front of the concave mirror. As a result, the image formed has a magnification of 3, but image is a real image. And because image is a real image, I have taken magnification as a minus 3. Magnification has a plus symbol, means image is virtual, erect. Magnification is a real, that means image is real, means a magnification will get a minus symbol. Okay, and later they said that if object is further moved by 10 centimeter, how much change in magnification will come? So from the first case, object distance, magnification, I was talking about this, magnification minus indicates in the question, they said real image, so minus symbol. So object distance, magnification and focal length, we will find focal length. Okay, so connecting these three, we have this formula. Now we'll put the values here. Magnification is a minus 3. Focal length of the mirror is our requirement. So f by f minus of the formula, but here object distance is minus 20. And then we'll go for a small cross multiplication to find focal length of the mirror. Keep this in mind. We will be right if a focal length we get negative. Why? Because concave mirror focal length has to be negative. So here we have f, which is minus 3f. Okay, minus of minus plus 20. You know, so we have minus 60. And then we'll have here 4f is minus 60 and f is minus 15 centimeter. Now we got focal length as a negative. This itself is a small hint that it is almost correct, because number wise we can't say, but symbol of focal length we got negative. So that is a hint, because the question is about concave mirror. Concave mirrors focal length has to be, concave mirror or lens focal length has to be negative. So right, so this is about case 1. Okay, so this is case 1. From case 1 we found focal length. Now we'll talk about what the question is. Case 2. Case 2, we are talking about the same mirror. When we are talking about the same mirror, focal length of the mirror is minus 15. So this is carry forward. then object distance will be what? They said object is a further shifted by 10 centimeter. Earlier it was a 20 centimeter away from the mirror. Now further change of 10 means what? 20 plus a 10. So object is at 30 centimeter from the mirror. But object distance always is negative. Okay, whatever be the mirror or lens. So we have focal length, we have object distance. When we find magnification, then we will know what is the change in image magnification. So for mirrors, magnification is f by f minus u. So this formula, if you can remember, you remember, or else we can derive from the basics. So here magnification is our requirement. So magnification in current status is minus 15 by minus 15 minus u is what? Minus 30. So this is what? Minus 15 by 30 minus 15. 30 minus 15 is 15. So magnification is minus 1. So this is the current magnification. But earlier also there was a magnification. Earlier, the magnification was minus 3. Current, based on the current location or position of object, based on position of object due to a mirror or lens, magnification. So therefore, decrease in image magnification. Of course, images are magnified, no? So we can just write magnification. Decrease in magnification, okay, will be the final minus the initial magnification. Okay, so that has a decreased by this. So this one. Final is minus 1, initial is minus 3. So this will be, okay. So decrease in magnification is the 2. So this is how it is done. Okay, to the mirror as I turn the pages of my book. And then, as you said, we'll go for derivation. And when I derive, I'll tell you what, we can do derivation in variety of ways. The book must have given one method. We can follow some other method. Ultimately, I'll derive for you mirror formula, mirror magnification. Okay. 44th question is also, but it is not a solving kind of problem, I guess. Just a moment, Sakshi. Unless I erase everything on the screen, I cannot magnify it. 44th question. 44th question. So we have a diagram. They said an object and plane mirror are placed in the position as shown in the figure, right? If object and mirror are moved simultaneously towards the right in the straight path at uniform speed of 2 centimeter per second and 5 centimeter per second respectively, find the shift in image of the object at the end of 10 seconds. Okay, so I'm not thinking it is a solving kind, but we will do some imagination work. So this is that principal axis, take it like that. Okay, so then we have a mirror. And we have an object. Okay, so this is the initial case. Then for a plane mirror, object distance and image distance are always the same. Okay, so did they give us any object distance? No, they. Okay, all right. So they have not given any object distance. Chalo, this is object distance, and its image distance will be same. So okay. Okay, so this is the actual condition. Then what they said is the object is moved towards the right side at a speed of 2 centimeter per second for 10 seconds. Okay, so distance moved by object, distance moved by object is, distance is speed into time, no? So speed into time, speed is a 2 centimeter per second, time is a 10 seconds. So distance moved by object is a 20 centimeter. Similarly, mirror is moved for 10 seconds at a speed of 5 centimeter per second. So distance moved by mirror is speed into time. So speed is 5 centimeter per second for 10 seconds. So this is 50 centimeter. All right. Okay. So the object is moved towards the right a 20 centimeter. So object moved by 20 centimeter, mirror moved by 50 centimeter. We'll remember this. So what is the new location of object? New location of object is O prime. It moved by 20 centimeter. Okay. And new location of mirror. Mirror moved by 50 centimeters. So right now I don't know where is 50 centimeters. So I'm just drawing this mirror somewhere. And this is the mirror location, the new mirror location. The same mirror moved by 50 centimeter. Okay. Right. So what is the new location of image? Okay. Earlier location of object, mirror, image in white. New location of object, mirror and image will be in yellow so that we understand. So chalo, the new image is here. Now what the question is, they said find the shift in image of the object. Shift in image of the object means we have to find the distance between the new image and old image. That means X we have to find out. So that's what they're asking. Find shift in image of object at the end of 10 seconds. Exactly. So this is what they're asking. So how do we find distance between? All right. So this distance should be equal to this distance. Okay, distance between object and image should be equal. Already we have a 50 centimeter. Okay, so what is the distance between O? I said there is a mirror. Okay, clear. There is a mirror M. There is an object. There is an object O. This object, O is object. Object's image is formed in the mirror. Okay, and in the mirror means we show diagrammatically to the right side. So this is the image. So you understand this is the object, this is the mirror, and this is the image. Okay. In the question, they said distance between object and mirror is 40 centimeter. They said this distance is 40. For a plane mirror, object distance and image distance are always the same. That means at what distance you are standing in front of the mirror, at the same distance your image will be formed. So this distance is also 40 centimeter. That's all. The first step is this. This is very.
How 40 centimeters?
40 is given in the question. Okay, while discussing, I missed it. You see, I have encircled on the question slide with blue. You see, this one I'm talking about.
Yes, ma'am.
In the question, it was in the statement they have not given, but on the diagram they gave. So that I just saw, and that's why I added that point in the after discussion. Okay, so first statement is this only. Okay, so object distance, image distance are same for a mirror. Later on, they said a very simple thing. They said this object is shifted towards right side. Okay, the current location of object is O prime. It is shifted by 20 centimeter, and the mirror is shifted by 50 centimeter. If that is 40, then the new mirror location will be beyond I know. So, okay. So this is the new mirror location. So mirror shifted by 50 centimeter. Okay. Now they are saying what is the distance between the new image and the previous image. All right. The new image is formed, say for example, somewhere here. This is the new image. Okay. Now for the current mirror location also, object distance, image distance should be same. Okay. Let's keep that in mind. Now you see, if this is a 40, this full length is 40 and this is a 20, then what is this distance? This distance is a 40 minus a 20 means what? 20 centimeter. Okay, then the new object and the new mirror location. Okay, that means what? This distance which I'm showing you with blue, that is called object distance for the current location of mirror and object, which is 20 plus 50. You see on the screen, you can understand from where to where I have taken. So that is 20 plus 50, which is 70 centimeter. Okay, so distance between object and the current location of mirror is 70 centimeter. So object distance, image distance should be same. So distance between mirror, current location of mirror and current location of image, that is image distance, that should be equal to object distance. And what is object distance? That is 70 centimeter. Okay, image. The question is shift in image of object at the end of 10 seconds. So shift in image means this distance we have to find, which is, yeah, this is, this part is 50 minus 40. So 10 plus 70, that is 80. Okay, it was not a numerical problem, but based on the ray diagram, we have to understand. Okay, yeah. So Sakshi, I just found these from reflection, and you said that example questions are accessible to you. So I'll go for the.
Yes, ma'am, I took.
Yeah. Okay. So what I'm doing is, and we can do it for concave mirror as well as convex mirror. So once I'll start with concave and then I'll go for convex. All right. So any one image formation I have to take for any location of a ray of light parallel to principal axis from the object after reflection passes through principal focus. This is one rule. And a ray of light through F, ray of light through F after reflection goes parallel to principal axis and they intersect between C and F. And image forms between C and F. This image is a real image. Why? Because this image is formed by actual intersection of reflected light rays. Okay. So this is one. So here how we prove it. For that, consider object is AB and image is A prime, take care. So we will consider, achha, this is a concave mirror, but concave mirrors are not so much cave-like. That means I want to say that this section of mirror where I have just drawn a straight line, this is almost a straight line. So we can have a triangle which I shaded white, and we can consider this triangle which I have just shaded. That means if I call this point as D, so something like a DP is approximately a straight line. DP is approximately a straight line. Why? Because we are taking a very small section of the mirror, or else you take that this ray of light which is parallel to principal axis is paraxial ray, means it's very close to principal axis. In that case, a DP is so close that it is a straight line. Take it like that. Okay, so we will consider first these two shaded triangles, and then we will take another pair of triangles. Okay, so now first triangle DPF is similar to triangle A prime B prime F. Okay, so this is A prime, this is a B prime, and F. How are the two triangles similar? The two triangles are similar by angle-angle similarity criterion. So you see vertically opposite angles are equal. And this is 90. That means the image is perpendicular to principal axis, and even DP is approximately a straight line. So this is also 90. For the two triangles, vertically opposite angles are equal, and angle A prime B prime F is equal to angle. So since those two triangles are similar, we will write that the corresponding sides are proportional. Congruent triangles, corresponding sides or angles are equal. Similar triangles, corresponding sides are proportional, corresponding angles are equal. Okay. So because the triangles are similar by angle-angle similarity criterion, I will write to B prime F. If you see what is a B prime F, see FP distance is the focal length. Okay, so though I'm writing there also small letter f, here also small letter f, but I'm showing you symbolically that this is focal length, and that f is a point. Okay, and B prime P is image distance between pole and image is the image distance. And what else we want? That's all what we want. Okay, so what is B prime F? B prime F is B prime P minus FP. All right, so B prime P is V, FP is focal length by F, and just leave it, call this as equation 1. All right, now we have to consider another pair of triangles. Okay, what pair of triangles can we consider? Just a moment. Right, so we can consider, I'll take up from the object the fourth rule, a ray of light incident at pole obliquely is reflected obliquely, but point of intersection of all the reflected light rays should be same at A prime. Okay, now we will consider this triangle ABP, this triangle, and A prime B prime P, this triangle. Okay, I have yeah, so one is this triangle, yeah, another is the above triangle. So we'll consider these two. So only for every whatever be the ray diagram you consider for deriving mirror formula or lens formula, one you will get vertically opposite kind of triangles, another you will get from poles. So once the triangles are similar, we will write the corresponding sides of similar triangles which are proportional, and always will start with image information to object information. So here also the bottom triangle A prime B prime P, So that triangles A prime B prime by the above triangles AB. That means altitude ratio, which is equal to the ratio of the bases. That is B prime P by BP. Okay. Now we want something else here. What is a BP? BP is the object distance. All right. In that case, what is a B prime P? B prime P. Okay, B prime P is a straightforward image distance from the diagram by BP. BP is again, okay, right, nice, not bad. Okay, so this is it. So from the diagram, so from 1 and 2, from equation 1 and 2, left hand sides are matching. So right hand sides have to be same. So what we'll do is from equation 1 and 2. So we have a V minus F by F is V by U. And we'll go for simple cross multiplication. We'll go for cross multiplication. So we will get VU minus FU is equal to FV. Happily put all the like terms together. We will have FV plus FU. Then what we do is, let's do a small common operation. Divide throughout by UV. As a result, left side, we will have 1. Right side, FV by UV is F by U plus FU by UV is F by V. So from numerator, you take highest common factor out, which is F, which is a 1 by U plus a 1 by V. Send that F the other side, it will go to the denominator. We call it as transposing. Okay. So this is a 1 by V plus a 1 by, I just wrote in order the way we remember. Okay, so this is mirror formula. Okay, and then mirror magnification. How to find mirror magnification? Okay, that's very simple in fact. Mirror magnification we will get from equation 2. Okay, equation, but we will put sign convention. Sign convention meaning here is, you see HI means image is below the principal axis. So we have to take it minus. HO is height of object. It is above principal axis. So it is a positive. V is image distance. It is to the left of the mirror. So it should be minus. U is object distance, which is left of the mirror. So it is minus. Okay. Then you can see that these minus cancel. And at the end of all the sign convention, we will have a minus a HI by HO, which is a V by U. Okay, so mirror magnification. Acha, I didn't tell you what is magnification, right? Just a moment. We have a definition for magnification. Magnification of mirror or lens is the ratio of, it is the ratio of size of image to size of object. If not this, it is the ratio of image distance to object distance. So it is the basic definition. But go for a combination of right side, you will take HI by HO is equal to minus of V by U. But one minus symbol is guaranteed for mirror magnification. Okay, so that's how we derive it. But I won't take up the ray diagram where object is at infinity and image forms at or on F, or appears to form at on or F. That I'll not take. So other ray diagram I'll take. So just see for convex mirror. So this is pole and F. I don't know whether I will use a C or not. Okay. Okay. So I'll take up some ray diagram here. So this is the object. And okay, object is not O this time. Object is AB. All right. Then we will have a ray of light from the object incident on the mirror parallel to principal axis. After reflection, it appears to diverge from a point on principal axis that is called principal focus. So this is the divergent ray. But we want one more also, no? But first, let us finish off the ray diagram. Then a ray of light incident in the direction of center of curvature. A ray of light in the direction of center of curvature. After reflection follows the same path back. And where these two rays appear to have intersected, there the image forms. So image is A prime, B prime. Okay, so first I will take a pair of triangles and then we will decide which will be better. I think with this itself we can do. So what combination? I will take a triangle ABC, this triangle, and it's an embedded triangle. Embedded triangle is A prime, B prime, C. A prime, B prime, C. Okay, these two triangles are similar triangles. I start there itself since triangle ABC.
Right angles and common angles.
Exactly, triangle A prime, B prime, C. So they are angle similarity. So I'm writing the CSST. So first image information, A prime, B prime by AB is the basis. Basis is what? B prime C by BC. All right, so left side I won't disturb, but what is the B prime C? Let's see, what is B prime C? First, this is the F, understood. In that case, this is the twice F, this is the V, and this distance is the U. All right, so I'll use these, one of those. B prime C. B prime C is what? B prime C from the diagram is the, B prime C is PC minus P B prime. Correct? Yeah, it's correct. PC, from the long length of PC, we will subtract P B prime. We will get B prime C. That's done. And then what is BC? Oh, nice. BC distance is BP plus, not minus this time, plus PC. Oh, okay. All right. So this one is A prime, B prime by AB is PC is twice F minus PB prime is V. Done. BP is U plus PC is twice F. Okay, now I can't do anything to this. I'll leave this one. Then I want one more pair of triangles. Which can be one more pair of triangles. Okay, just I'm trying upon one more pair of triangles. Say I go for one at pole reflected. Okay, and I just take this back. Then what triangles will I get? Yeah, I'll get this triangle. A prime, B prime, P. A prime, B prime, P. And ABP. I'll get these two triangles. Nice. Okay. So this and this are equal. Okay. So in that case, I and, okay, so these two. This equal to this, but this equal to this. So angle APB is equal to angle A prime, P prime, B prime. Okay, that is one. Another is the right one, angle ABP and A prime, B prime, P. So those angle similarity. And thus, we'll write the ratio. Just a moment, So image information, that is A prime, B prime by AB is PB prime by BP. Okay, take. What is PB prime is image distance and BP is object distance, right? Done, almost done. So from 1 and 2, from equation 1 and equation 2, left hand side matching, so right hand sides are matching. So I'm writing twice F minus V by U plus 2F. On the other side, V by U. And a simple cross multiplication should give us our answer. 2FU minus VU is VU plus 2FV. Okay, put the like terms together. 2F, I can write U minus V, and this left side UV to the other side gives 2 UV or 2V, like this. What did I transpose? I'll tell you. I have exchanged these two. I have exchanged those two. Okay, and just one step ahead of this, we have here the common operation, divide throughout by UV or VU. So we'll have here twice F U by VU minus twice FV by VU. On the other side, we have only 2. And then whatever cancels, let them cancel. Okay, and we are left with, you take 2 on the either sides, left side 2 highest common factor, that cancels with right side 2. So F is highest common factor, balance 1 by V minus 1 by U. On the other side, you have 1. And you must have understood by this time, this implies you have 1 by V minus 1 by U is 1 by F. Okay, so this is how we derive a mirror formula from this. And mirror magnification is also like that. From mirror magnification is image information to object information. So from second equation itself, we'll get mirror magnification, which